This is a quick tutorial on how to make a scatter plot. It's something that you should take notes on. It's not in your textbook, but I would expect for you to fully understand how to do this. We're not going to go over it in much detail in class. So the first thing you draw when you draw a scatter plot is your axes. Alright, so when you draw your axes, one of the things that I expect is that you must use a ruler. And so to make things very clear, I have for you a bad/awesome example. Alright, in the bad example, you can see that clearly the lines here were drawn without a ruler. And this makes me, well, should we say, sad face. Alright, if you give me a graph like that, I'm going to give it back to you without points. On the other hand, your awesome graph is clearly drawn with a ruler. That is an awesome graph. That's going to get a smiley face and probably some points. Alright, so it's that simple. If you're drawing a graph, you better be on graph paper, and you better be using a ruler. I expect neat data presented well. Alright, if you're doing a graph, you need to label all of your axes with both the measurement and the units. Label all of the axes with measurement and units. So that means that there's no such thing as putting in, oh, this is time and this is length. Alright, that would be bad. Even if you said this is time in seconds and this is length in meters, right, that's a little bit better, but you're still missing any of your data points. So let's say you left those off, right, and you were just like 1, 4, 7, and then this is 1, 2, 3. Alright, that's still bad because I don't know what your units of measure are. On the other hand, if you're going to give me an awesome graph, then you would give me the measure, for example, time in seconds, 1, 2, 3, 4, with the distance in meters. This is awesome, folks. Alright, this makes me happy. I know what is on the x-axis, what is on the y-axis, and what units were used to measure them. It could be centimeters, it could be micrometers, it could be kilometers. That's fine. Just make sure that you label them, because otherwise, what are they? Make sure that your axes don't have to start at 0, but if they can, they should. So for example, right, don't make that your 0 right there. You can very easily bring your 0 down to here. So on this graph, for example, since we're starting down at 1, right, that can make our intercept 0, 0. I'm sorry. Our intercept here can be 0, 0. So that's awesome. Your values on your axes must be evenly spaced. Right? One of the things that you might see on some bad graphing is, let's say you start with a value down here at 1, and your last value is 500. And so you have 1, 2, 3, 50, 250, and then your data goes like this. Alright, that's bad, because there's more space between this 1 and 2 here than there are between 3 and 50, and that's not actually representative of the way that you might actually see data. On the other hand, right, if you're going to evenly space your data, you need to figure out how much space your data is going to take up. So in this graph we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 spaces, and if we need to get 500 meters on there, 500 divided by 20 means that each of these is going to represent 25. Right? And that's evenly spaced. And so far this graph is remaining awesome. Now, one of the quick things for you to remember when you're making an awesome graph is what your x-axis and your y-axis represent. The x-axis is always the independent variable, and the y-axis is the dependent variable. So here's a way to think about it. If you are measuring something against time, time is always going to be your independent variable, because it doesn't matter what you do with yourself, time is still going to pass. Time doesn't only pass when you move. Time will always pass, and time will always pass in equal increments. Time will always continue passing with second after second after second. However, something like distance will only change over time. Right? If you are moving, some seconds have to pass in order for you to make it to the 2-meter mark, the 3-meter mark, the 4-meter mark. So that means that anytime you're dealing with time, time is always your independent variable. And whatever is happening because time is passing or while time is passing would be your dependent variable. So you're going to see that that is in fact represented on our awesome graph. Time is our independent variable. Time will continue to pass whether we want it to or not. Whereas distance, right, or displacement, which would be more correct, is going to depend on how much time passes along with some other variables. So now we're going to come to plotting points. All right, when you've got yourself an awesome graph, you're going to be ready to plot points. And some of your data, some of the things that you collect might not be awesome, but it doesn't matter because you always need to plot all the data points. Right? So if you've got data and you're like, okay, so on my graph, this one was good, and this one was good, and this one was good, and this one's down here. I'm gonna cross that one out because it doesn't fit in. And then this one was good, right? So you're not allowed to do that. This is science. You collected that data. Every single point better get plotted. So when you plot your data, no matter what it looks like, all of your data points need to be plotted. All right, that is what an awesome graph is going to look like. One of the things you don't need to do is you do not need to label all of the data points. That's something that maybe you've learned to do in your math class, is you've learned to plot that this is 4, 5, comma, 1.75, and you tell me what each one represents. 1, comma, 0.5. Right? And you're not going to be doing that in this class. In fact, that's the reason that we have such a well-labeled and evenly spaced graph, is so that you don't have to fill the graph up with clutter. So don't label each individual point. It's not important. All right? And then another thing that you need to make sure that you do is you need to make sure do not connect the dots. All right, this is not first grade. We're not doing a dot to dot. All right, you're not going to be saying, oh, well, this one connects with this one, which connects with this one, which connects with this one, which connects with this one. That doesn't tell you anything about the trend, right? That's pretty darn sucky. You don't want to do that. We don't connect the dots. All right? But what you want to do is you want to make sure that your graph has a title. Right? And that title is always going to be the dependent versus the independent. So if we're going to name our graph here, right, our awesome graph is going to be distance versus time. And like I said, in making this even more correct, especially if we're talking about vectors, we might want to call this displacement versus time, which means we'd want to rename our axis over here displacement. Now that's pretty good looking. But there's probably more to it, because right now we have a pretty great scatter plot. And you're going to notice some of you might be getting a little bit itchy because it's not perfect, right? I've crossed something out, right? But it's still exactly as it should be. And in your laboratory notebooks, this is how I would expect to see it, because if you do make an error, you don't tear anything up and start over again. You line it out and add it. This is the way real data is collected. All right. The next thing that you're going to do is you're going to add a line of best fit. And the line of best fit is always just a smooth line or curve that shows the general trend of the data. It's, for the most part, when you're collecting real data in the real world with real human error and real instrument limits and real problems, your data isn't going to be perfect, but you have to decide what the general trend was and the relationship between your data and the general trend. So here we're going to see that even though not all the data can fit through one line, we want it to, as best as possible, go through as many points as possible, or through the average of the points. And we add a line of best fit. This is especially going to be important when we talk about the relationships between our x and y axis, because if we have a straight line, that's going to be a y equals mx plus b relationship. If, on the other hand, for our data, imagine, if you will, that we had a curve, right? Then we have to decide what's the relationship between our x and our y variable. Well, depending on what type of curve, we can have a relationship between y and x squared, or we could have the relationship between y squared and x, or we could have a relationship between y and a root of x. Right? You have to determine what that relationship is, and a lot of the time when we're looking at concepts, we're going to be guiding in them. And so if you don't have a straight line, you have a curve, we're going to have to figure out what relationship your curve represents. And sometimes the equations can guide the graph, sometimes the graph can guide the equations. And we're going to take a look at that, but we'll of course start with just looking at basic relationships on a scatter plot. So be ready to do this in class. We're going to start with some graphing activities on Friday.